Hello friends, welcome my channels. Today's discussions is uniform continuity. So friends, at first I want to discuss the definitions of uniform continuity. A function fx is defined on an interval I is said to be uniform continuous in I if and only if for every epsilon greater than 0. Must remember friends, for every epsilon greater than 0 there exists a del greater than 0 independent of the choice of any part I. I means interval such that fx1 minus fx2 less than epsilon whenever mod of x1 minus mod of x2 whenever mod of x1 minus x2 less than del, where x1 minus x2 are any arbitrary point in I, where x1 minus x2 are any arbitrary point I. So friends, I have already drawn a diagram. You will see that this point is this is the x1 point, this is x1 and this is x2, and this is fx1, this is fx1 and fx2. See that friends, and now you will see that fx1 minus fx2 mod of fx1 minus fx2 less than epsilon, and x1 whenever mod of x1 minus x2 less than del. So friends, you see this is the point x-axis and this is x-axis, this is x dash axis, this is y-axis and this is y dash axis. So friends, this is the conditions, and now if you have to remember that epsilon is dependent on del, or del is dependent on epsilon. So friends, we know these conditions, we know this is the condition. So friends, this is the uniform, then it is UC. Now we are discussing a questions. Now we are going to a questions. We ask a questions. This question is very important and very common. This is the questions. Fx is equal to 1 by x, where x belongs to 0, 1. Solution. Let's draw a line. This line is x and this is the y and this is the point 0. So friends, the curve is, this is the curve. Now I have chosen one point x1. This point is x1 and this point is x2, and I get in here fx1. This point is fx1 and this point is fx2. So friends, this kind of problem you have to, we know this is the fx1 and this is the fx2. This point is fx2, and this is the fx1 and the fx2, friends. And you will see that this distance is epsilon, and this distance is also del. Now I shall change the distance between distance between fx1 minus fx2. Here I will write fx1, this is fx1, this is fx1, and this is fx2, and my changing line is, this is my changing line, this is my changing line, this is the epsilon. I change epsilon distance. So friends, let's see that this line should be this, and this is the this is the x1, and this is the x2. Must note that this is x2, this point is x2, and this point is x1. So friends, according to changing x2 minus x1, this distance and this distance both are different. This distance is del, this is del, and this is del 1. So x2 minus x1 means mod of x2 minus x1 less than del. So friends, if I will change epsilon, means fx1 minus fx2 less than epsilon, I get del according to the point. Del is depending, this means del is depending on point. So friends, if del is depending on point, so hence 1 by x is not UC. UC means uniform continuous. UC on 0, 1. So friends, I hope I can clear this concept. Whatever I can clear that when it is uniform continuous, then del is dependent on epsilon, but here del is not depend on epsilon. So, but it is dependent on point. Next friends, we will go to the another point, another topic, another questions. Show that the function fx is equal to root x, where x belongs to 0, 1. So friends, whatever we see that fx is equal to fx1 minus fx2 mod of fx1 minus mod of fx2 equals to mod of root over x1 minus mod of root over x2. And now you can write this way: mod of x1 minus mod of x2 divided by root over x1 plus root over x2. And now it can be written this way: it is less than x1 minus x2 mod of x1 minus x2 root over x1 and it can be written mod of x1 minus mod of x2 root over minus x1 minus x2 equals to root over x1 x1 minus x2 and less than del. So friends, less than del means less than epsilon, and here and that implies mod of x1 minus mod of x2 less than epsilon square, and this is del. So del is depending on epsilon square. So hence the function fx is uniform continuous. Next friends, next problem, next I will discuss the property of uniform continuous. Necessary and number one, if fx is continuous on a comma b and limit exists finitely at both ends, then fx is UC, uniform continuity on a comma b. This condition, this is the necessary condition. I discuss necessary condition, but not sufficient. Necessary condition. This condition is necessary condition. And number two, if fx is continuous on a comma b, then fx is uniform continuous on a comma b. Number three, if fx is continuous in a comma infinity and limit extends to infinity, fx exists then fx is UC, uniform continuous on a comma infinity. So friends, this property is necessary, but this is not sufficient. You must remember that if it is sufficient, then it is different. Next friends, next we go example questions. Which of the following are UC on 0, 1? So friends, which are following of the UC? Number A, e to the power x, number B, 1 by x, number C, x square, and number D, none of these. Answer. Let's start answer. Limit exist both e to the power x at zero and 1. So e to the power x is uniform continuous. 1 by x is not uniform continuous. I have already told, and x square is continuous because that the 0 and 1 limit is exist, and none of this is our answer. Thanks for watching.